In this video, we'll be doing a couple more examples of integrals of exponential functions. Our first one is to evaluate the integral of sine theta times e raised to the cosine theta d theta. Now we need to let u equal cosine theta, and then when we differentiate we get du is equal to a negative sine theta d theta. So my problem has a sine theta and a d theta factor, and so I need to get this negative sign over onto the left side. So I'll divide both sides by -1, and I have a negative du is equal to sine theta d theta. Now if we do our substitution, this becomes the integral of, and I'll save my sine theta d theta for a little bit. I'll do my e raised to the u, and then sine theta d theta I'll replace with a negative du. The negative we can bring out in front, and then we know that the integral of e to the u du is e to the u plus a constant. And then finally we need to sub back in place of u. I'll put a cosine theta. So I have negative e to the cosine theta plus a constant. Let's do another one. In this example, we're asked to evaluate the integral of e to the 2t divided by the square root of e to the t plus 1 dt. So let's let u equal the square root of e to the t plus 1. Now to differentiate this, I'm going to square both sides just to make my work a little easier. So then I have u squared is equal to e to the t plus 1. And this is actually not in the exponent, so let me write that a little bit bigger. This is not in the exponent either. It's just e to the t plus 1. Okay. Now when I do a derivative on this, I have 2u du is equal to, the derivative of e to the t is e to the t, the derivative of 1 is 0, and then dt. So my problem then, I'm going to sub in for dt. Let me write this as dt is equal to 2u du divided by e to the t. Now if I'm going to sub in a u, I'm going to need an expression for this e to the t. So I can take this equation and see that if I subtract 1 from both sides, that gives me e to the t is equal to u squared minus 1. So I'll put this in then in place of e to the t, and I get dt is equal to 2u du divided by u squared minus 1. Now I'm ready to sub in. So my integral, in the numerator, I have, by the way, this is the same as e to the t squared because remember you multiply the exponents when you have a power to a power. So my numerator on my integral, e to the t is u squared minus 1, and then that's getting squared. So u squared minus 1 squared. And then in the denominator, square root of e to the t plus 1, that's just u. And then in place of dt, I'm going to write 2u du over u squared minus 1. Put that in parentheses. Alright, now I can do some simplifying. This u can cancel with this one. And this binomial factor u squared minus 1 can cancel one of those. So my integral simplifies to, and I'll pull my 2 out in front. 2 and then u squared minus 1 du. This is 2 times u to the third power divided by 3 minus u plus a constant. Now I just need to stub back in place of u. I need to put the square root of e to the t plus 1. Since I have an exponent, I'm going to write that as 1/2 power. So e to the t plus 1 to the 1/2 power, and then that's cubed over 3 minus, and then again e to the t plus 1 to the 1/2 power. Okay. The only simplifying I need to do is to distribute this 2 back into this bracketed expression. So 2 multiplied here is 2/3, and then e to the t plus 1, and I multiply these exponents, so that's raised to the 3/2, minus, and then 2 multiplied here gives me 2 e to the t plus 1 to the 1/2 plus a constant.